Hi, welcome back. This is an example of our other trig functions. I'm Professor Steele. Here's a situation that we've been given. Cosine of alpha equals 8/9 and is in quadrant 4. Find the exact value of the other 5 trigonometric functions. We want to use the unit circle. Now recall our 5 trigonometric functions. What are those? The other 5. We're talking about our sine of alpha, our cosine of alpha, tangent of alpha, the reciprocal of sine, which recall is our cosecant of alpha, reciprocal of cosine, which is our secant alpha, and the reciprocal of tangent, which is our cotangent alpha. So before we begin these problems, always visualize. You've been given information. Cosine of the angle is 8/9. Recall, cosine measures what? The horizontal length of the angle. And it's in quadrant 4. So we have a horizontal measurement of 8/9 for an angle that is in quadrant 4. We know this is our unit circle with a radius of 1. So 8/9 would roughly put it in over here. So we have an angle that has a horizontal measurement of 8/9. There is our angle alpha. Now, which one of these would be the smartest move to fill in first? We already know cosine. And you should be thinking, well, there's the reciprocal right next to it. What does reciprocal do? It flips our value. Even on your calculator, the reciprocal is always the 1/x button. Remember that. So there's our cosine value. We know we have a radius of 1. So what information do we have and what can we use to figure out our vertical measurement? If you've said Pythagoras, you've nailed it. So we have our vertical measurement, which happens to be our y coordinate, plus that 8/9. What am I using here? Our Pythagorean theorem. So y squared, if I try to isolate our y, is 1 squared minus 8/9 squared. Now, again, note, exact values. Exact values means don't jump to your calculator, leave it in simplified radical form. So we have 1 squared, which is 1, minus 8/9 squared, which is 64/81. And we want the square root of this since we want y. So y equals, okay, let's do some basic algebra. 1 minus 64/81. 1 is what? It's 81/81. So 81/81 minus 64/81 is, some mental math here, 17/81. Now we have to take the square root of that. We can't take the square root of 17 without it becoming a decimal, so we are going to leave it as square root of 17. However, the square root of 81 is 9. So we have now figured out this vertical measurement is radical 17 over 9. However, note it's in the 4th quadrant. So what do we have to be careful of here? When we took the square root, we actually have 2 values we could have had. Our positive and negative radical. Looking at the location of where this angle falls, that tells me that we want the negative value. So coming back to our other 5 trigonometric functions, which one did we just determine? Our sine of alpha is negative radical 17 over 9. Again, what makes sense to do next? We go over to our cosecant, reciprocate that value. Negative 9 over radical 17. Now we're moving into our tangent. Recall, tangent, as we've mentioned before, is sine of an angle divided by cosine of its angle. If I take sine, negative radical 17/9 and divide it by 8/9, I don't need to worry about the fact that they're ninths. That leaves me with negative radical 17/8. how many negative radical 17/9 can be divided by 8/9. That gives us negative radical 17/8. Similarly, we can now reciprocate this, and we end up with the value of negative 8 over radical 17. Let's verify. Let's ask if this is reasonable. Is my tangent and cotangent, does it have a slope that is negative in this quadrant? And yes, it looks like through our unit circle, we have a negative slope. So this is the type of example that you will see that culminates all our other trigonometric functions into one problem. I hope this video helped. Thanks for watching. Please click on the Edvantage logo, like and subscribe, and I'll see you next time.